Have you ever been in a meeting and felt like the IT folks were speaking a completely different language? Throwing around all those acronyms, LAN, WAN, DNS, DHCP? Well, today, we're going to crack that code. We're going to demystify the absolute essential language of computer networking so you can finally understand what is really going on every time you connect to the internet. And this is such a perfect way to think about it. The network isn't just a bunch of cables and blinking lights. No, it's the central nervous system that lets an entire business operate. If the network goes down, guess what? The business goes down with it. So, understanding its language, that's absolutely crucial to understanding the health of the whole organization. And that's really our mission today. We are not just memorizing a dictionary of terms. By the end of this, you're going to get the core concepts that network engineers in a network operations center, the NOC, use every single day. You'll actually understand the fundamental logic of how your data gets from point A to point B.
So, where does this whole journey begin? Let's start with the connection that's most familiar to all of us, the one between your laptop and all the devices right there around you. We're talking about the local area network, or what everyone just calls the LAN.
Okay, so every single conversation on a network starts with a piece of hardware called a network interface card, or NIC. Think of this as the physical gatekeeper for your computer. It might be that Ethernet port you plug a cable into, or it could be that tiny Wi-Fi chip buried inside your laptop. The point is, without a NIC, your computer is on an island, totally isolated. Once you're physically connected, your device needs an identity, and that's its IP address. The street address analogy is perfect here. It's a totally unique number that makes sure data packets being sent across the network actually arrive at your device, and not, your colleague's laptop by mistake. All right, so your device has an address, but what neighborhood is it in? Well, there are basically two types of networks you need to know. The LAN, the local area network, that's your immediate digital neighborhood, your home Wi-Fi, the office network, and then there's the WAN, or wide area network, which is what connects all those different neighborhoods together across cities, countries, and even continents. The internet, that's the ultimate WAN. So how do all the devices in your little local neighborhood talk to each other? They do it through a device called a switch. The best way to think about a switch is like a smart mailroom for your office. When your computer sends a file to the printer, the switch makes sure that data goes only to the printer, not to everybody else on the network. It's the intelligent director of all your local traffic. So we're all connected locally. We're talking to each other, things are good. But what happens when you want to check a website? That request has to leave your local network, and it has to find the door to the wider internet. So how does it do that?
Well, that is the job of a router. Now, remember how a switch connects devices inside one network? A router is different. It connects different networks together. It's like the traffic cop standing at the big intersection between your local LAN and the massive internet WAN, and its whole job is to direct your data onto the best possible path to get to its destination.
But how does your computer even know where to send data that's supposed to go out to the internet? It sends everything to one specific place, the default gateway. This is usually the IP address of your router. You got to think of it as the one and only designated exit door for your entire local network. Any data that needs to get outside has to go through that door first.
Okay, our data has officially left the building. It's now cruising on the information superhighway. But how does it communicate effectively? Well, just like real highways, there are established rules of the road. In networking, we call these protocols, and they make sure data gets where it's going safely and reliably. Now, two of the most important protocols you'll hear about are TCP and UDP, and they really represent this fundamental trade-off. See, TCP is all about reliability. It actually makes a connection and confirms every single piece of data arrives safe and sound. It's perfect for something like an email, where you need every single word. UDP, on the other hand, is all about speed. It just blasts the data out there and kind of hopes for the best. This is great for video streaming, where losing one tiny frame is way better than having the whole video just stop and buffer. It's this constant choice, right? Reliability versus speed. Let's talk about DNS. The domain name system might be one of the most critical, unsung heroes of the internet. And the phone book analogy is spot on. See, we humans remember names, like Google.com. But computers, they only understand numbers, those IP addresses. DNS is the service that does the lookup. You type in the name, and DNS finds the correct number so your browser can connect to the right server. Without it, the internet would be unusable. So we know every device needs its own unique IP address. But could you imagine having to manually type one in for every single phone, tablet, and laptop in a huge office? It would be a nightmare. And that's where DHCP comes in.
The Dynamic Host Configuration Protocol is a service that just automatically hands out a valid IP address to any device that joins the network. It's an absolutely essential time saver.
All right, so we've covered how everything is supposed to work in a perfect world. But what happens when it doesn't? Let's put some of this new vocabulary to use and see how an engineer thinks when they're troubleshooting a really common problem.
We've all been there, right? You click on a link and you just get that spinning wheel of death. It just spins and spins. You're getting frustrated. So when an IT engineer gets that dreaded call, the internet is slow, what is the very first, most fundamental question they're going to ask to start figuring out what's wrong?
Can you ping it? This simple question, right here, is the absolute bedrock of network troubleshooting. Before they start diving into complex things like firewalls or applications, an engineer needs to know the most basic thing. Is there even a connection? Can my computer send a signal to that destination and get any kind of response?
So what is a ping? It's just a simple diagnostic tool. It sends a tiny little test packet across the network. It's basically like shouting hello into a dark cave and waiting for an echo. If the other device is reachable, it sends a reply back. And that ping result tells you two critical things. First, if you got a response at all. And second, how long it took to get back, which helps you diagnose both connectivity and lag.
Now this brings us to a super common point of confusion, the difference between bandwidth and throughput. Think of bandwidth as the number of lanes on a highway. You might have this massive 8-lane superhighway, right? That means you have high bandwidth. But if there's a huge traffic jam, the actual number of cars getting through, that's your throughput, is really low. So when your internet feels slow, the problem isn't always the size of your connection. It might just be a bottleneck somewhere.
And the other major reason for a slow connection is latency, or what most of us just call lag. It's simply delay. It's the time it takes for a data packet to travel from you to a server and all the way back again. That's actually what a ping measures. Even if you have a huge, empty 8-lane highway, if it's thousands of miles long, every trip is just going to take a while. High latency makes a network feel slow because every single click has that little bit of delay built right in.
Okay, you've made it. You've got the basic architecture, the protocols, and even some troubleshooting basics down. So to wrap things up, let's have a little fun and cover a couple pieces of insider lingo that you might actually hear from network engineers on the job.
If you ever hear an engineer say, "Looks like the pipe is full," you now know exactly what they're talking about. No, it's not a plumbing issue. It's just slang for we've completely maxed out our bandwidth. It means the actual throughput is hitting the theoretical limit. Every single lane on our highway is totally full of cars.
And finally, we have a classic piece of IT humor. After an engineer has checked absolutely everything, the cables, the ping, the protocols, all the hardware, and they find nothing wrong, they might just sigh and declare, well, the problem is layer 8. But what on earth could that mean? You see, the standard technical model for networking has 7 official layers. Layer 8 is the unofficial joke layer that sits on top of all of them, the user. It's a funny way of saying that after all the technical troubleshooting is done, sometimes the problem isn't with the network at all. And it's a great final thought, a reminder that you always have to consider the human element. And that's a lesson that applies far beyond the world of IT.